Trigonometry 8.5. I'm working through a sheet of notes titled 8.5 at the top corner. So the main theme of 8.5 is a thing called combinations, which we have not talked about in this chapter 8. So first I'm going to differentiate between combinations and permutations versus factorials, and I'm just reading off of this paper. Today the homework is going to deal more with combinations. There will be, actually in the homework, every problem will be a combination problem. Combination problems are ones where the order does not matter. And those numbers for your answers are usually going to be smaller than what you've been dealing with in the previous sections when we did permutations. Permutations are where the order does matter. Those have been giving us sometimes very large numbers of choices when the order does matter. Factorials we have used occasionally. Those are permutations because the order was mattering, but they're where all the items get used up. So if I tell you, if we work through our bottom group here and this middle group here, if I tell you to pick a team, I put a C next to that choice because that's a combination. It doesn't matter what order you pick the people on your team. If I say I'm picking a team, it's me, Nina, Daisy, and Alyssa. That's the same team as if I say I'm picking a team, it's me, Daisy, Alyssa, and Nina. It's me, Nina, Daisy, and Alyssa. It's Daisy, me, Alyssa, and Nina. No matter the order I pick that's all the same team we end up with in the end. Picking a team would be a combination problem. They'll do some of those in the homework. If we're going to do a seating chart for a class, that's a permutation. It's very different if Nina sits next to Zach than Nina doesn't sit next to Zach. If you don't believe me, just ask Zach. That would be a very different experience for him depending on the seating chart. The seating chart, order would matter. That's a permutation problem. By the time we get to the test, I will blend these together, and you'll have to be able to recognize a permutation versus a combination. But for tonight's homework, everything's a combination. There's no real thought on this. We have made words before. When you have a word, the order of the letters absolutely matters. This is a different word than that, is a different word than this. And those all actually are words. But if I start going like this, my left with okay. If I say we're doing permutations, the order matters. There's 6 choices there. If I say the order doesn't matter, just grab 3 letters out of a bin for your little brother's toy, that's a very different situation. But if we're forming words, order matters. That is a permutation. So I put a P next to that one. If we were going to pick a committee, that's just like picking a team. Hey, the prom committee is Allison, Danielle, and Avery. Hey, the prom committee is Avery, Danielle, and Allison. It doesn't. It's the same committee. It doesn't make any difference the order in which we name them. If you're going to be dealt a hand of cards, that is a combination problem. If you've ever played any cards, you know they get dealt to you usually face down. You pick them up. The first thing you do is probably shuffle them to put them in some kind of a pattern that you know what's where. You still have the same cards. Okay? The order that you sort them makes no difference as to the strategy of playing the game. You've got the cards. The order did not matter. It didn't matter if you got the blue 2 and then you got the red 6 if you're playing Uno, or if you got them in a different order. It does nothing for you. Positioning a team would be a permutation. We've done those kind of questions before. Having one person be the point guard is very different than having another person be the point guard. The order there matters when you start talking about positions. Shelving books, the order matters. That's a permutation. If you don't believe me, just ask a librarian if they care where you put the book on the shelf, because they will. To be able to do math with those stories, I'd have to give you some numbers. So let's retread some numbers. So if I told you, like, you have 10 people, pick a team of 5. A new way we could write that would be 10C5. Picking a team is a combination, because the order didn't matter. But if there's 10 people to choose 5, 10C5 is a way we could write that. Seating chart, I don't know, for trig, there's 7 of you. So if I say I'm going to make a seating chart for all 7 of you, I could go 7P7. There's 7 of you, all 7 are going on the chart. It'd be sort of awkward if I had a seating chart for 5 of you and the other 2 just stood in the back. So 7 people, seating chart for all 7. Another way you could do that is 7 factorial. We're doing words. I have 10 letters to choose from, and I'm going to build 5-letter words. That would be 10P5, because permutations, the order matters. So 10P5 on word for me. Picking a committee. There's 8 seniors. Pick a committee of 3 to plan the prom. You could have that as 8C3. If we're going to be dealt a hand of cards, I could say like 52 cards in a deck, I'm going to deal you 7. I could write that as 52C7. The total amount comes first, the amount I'm choosing to give you goes second. Positioning a team. There's 12 people on a basketball roster, put 5 of them on the floor to be starters. That would be 12P5 if I gave them positions. Or I'm going to shelf books. I'm working at the library, somebody brought back 10 books. I'm going to shelve them all. I could go 10P10. Or alternative plan 10 factorial. You have calculator buttons that let you do this, so let me coach you up on some calculator buttons. If I want to punch in 10C5, the quickest way to do that from now on is punch 10, hit the math button, go over to the probability column, go down to choice 3 where it says NCR, and then punch the 5 and hit enter. That is 252. 7 factorial we've done before. You would do the 7, you would do math, you'd go over to the probability column, down to the 4th choice, factorial, and that is 5040. 10P5, we go 10, math button, over to probability, down to choice 2, NPR, and then do the 5, and that's 30,240. And as I mentioned earlier in the period, the P choice is usually big. The C choice, usually not so big. When you go to do the homework tonight, you can do about half of it right now. We'd be working from page 250. It starts off 9 through 16, I believe is the start of that. No, 9 through 12 is just punching buttons. When you punch a button on 9 to 12, you'll notice those 4 are special. You'll see it when it happens. Then we're going to work from 17 to 28. You would be more or less okay 17 to 28 because there are going to be a lot of stories like I just did here. There were 10 of whatever and we chose 5. 10C5, we punched it. So they're going to tell you stuff like your pizza shop has 12 toppings, you're going to get 3 on your pizza, how many pizzas could you get, different ways you could create a pizza, 12 toppings, pick 3. So you go 12C3, punch it in, or they're telling you there's 8 of this, you get 3, 8C3, you punch it in. That's going to be how largely it works out to 28 with a few twists toward the end. 29 the game changes, so I need to do some more examples and I'll be working my way to your left here in a minute. I'm working from page 249 now. There's an example 4 that talks about some different things. Anytime they say probability, you need to be thinking about fractions. So they tell you there's a committee of 5. They're going to select from a group of 9. As soon as you have that information, you have the bottoms of every fraction answer made ready for you. If there's 9 people and they're choosing a committee of 5, every bottom of every answer is going to be 9C5. There's 9 people, you're going to select 5, that's just the bottom. They then give you some choices here. So for choice A on page 249, they tell you you have to take Eileen. That just gave you one choice. They say and, so I'm going to multiply because and continues to mean multiply. You have to take Ben. That is one choice. You have to take Ben. And there's another thing going on that they haven't told you. If you had to take Eileen and you had to take Ben, you have some flexibility of how you're going to pick the rest of the people. It's like this, but there's no longer 9 positions open and 5 people, or 9 people to choose from and 5 open positions. What you have going on now in your life, you've picked Eileen and you've picked Ben. You're now looking at a group of 7 remaining people because you took 2 of them out of play. But you're no longer looking to fill 5 slots on your committee, you're looking for 3. Eileen has a job, Ben has a job. You're not filling 5 jobs anymore, you're filling 3 jobs. To punch this in, you don't have to punch in the ones. You could just do 7C3 divide by 9C5, punchy, punchy, punchy. They go fraction or percent. I'm fine with decimals. So you can go with a 0.28 would be fine with me on that. For choice B, they're doing 3 women and 2 men. So we're going to need to do a group of women and as multiply, do a group of men. If we're going to do 3 women, I believe there were 6 women to choose from. Yep. So 6 women to choose from, you took 3. And in the men, there's 3 men to choose, take 2. You could just punch this in, 6C3 times 3C2 divide by 9C5, punchy, punchy, punchy. We're hoping to be around a 0.40. For choice C, this is going to be a long one, so I'm going to write some English first and then translate the math. They're telling you that you have at least 3 women. So if you have at least 3 women, you could have 3 women, or you could have 4 women, or you could have 5 women, but you can't have more than 5 women. There's only 5 jobs on this committee. Okay, so if they tell you there's at least 3 women, there's 3 women, or means add 4 women, or means add 5 women. That's your choices. But you can't just take women, you also have to take some men. So we might have 3 women and 2 men, because we need a 5-person committee. So one way you can build your committee is with 3 women and 2 men to just fill it out. If you're picking 4 women, you also have to have 1 man. If you're picking 5 women, you would have no men. And these places that I said and need to be multiplies. And everywhere I did a group of people, I need a C. So again, the way we could build this committee, if there's at least 3 women on it, there could be 3 women and 2 men on a committee, or there could be 4 women and 1 man on a committee, or there could be 5 women and no men on a committee. And everywhere I had an and, I multiplied. Everywhere I had an or, I added. Some of the bigger questions, you may need to go English before you can go math. For the women, there's always 6 women. I'm taking 3. Here, there's 6 women. I'm taking 4. This has 6 women. I'm taking 5. For the men, there's always 3 to choose from. 3 men this time took 2. 3 men this time took 1. 3 men this time took none. A good quick check to do is usually within each group, add the beginning numbers to make sure it added to the beginning. Add the ending numbers, make sure it added to the end. And that'll happen throughout. Beginning numbers add to 9, finish numbers add to 5. Beginning numbers add to 9, finish numbers add to 5. For you to punch this in, the whole talk, because it's adding, will need to go in parentheses. But you could go parentheses 6C3 times 3C2 plus 6C4 times, etc., 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 and so forth. Cut the parentheses, divide by 9C5, punch it a punch it a punch, and we're hoping for something around about a 0.88. Then the last thing on your notes, it said deal cards. So step to my right and I got some card dealing questions. So I'm doing a 52 card deck and I'm going to deal you 13 cards. So the bottom of every question I ask is 52C13 because there's 52 cards, I'm giving you 13, that's a guarantee, every story, that's what we're doing. For this question, quick reminder of the suits. There's spades, there's clubs, there's diamonds, there's also hearts, there's 13 of each type. If I deal you 3 spades, I need to do a C for the spades, 13 spades, pick 3. But then I have to take notice that there's other things going on. Like a minute ago, I only talked about the women. I had to think about the fact there's men too. On this problem, there's not just 3 spades. There's an and to multiply. There's 10 others. If we're trying to get 13 cards and 3 are spades, there's 10 other cards out there doing whatever. Out of those other suits, there's 10 cards to choose. There's 39 to choose from because there's hearts, diamonds, and clubs. 13 of each of those 3 is 39. Again, quick check. The beginning numbers should add to 52. The final number should add to 13, and that's confidence inspiring. If you punch this in, you should get a .286. This one, I'm doing spades, so a C for the 13 spades. I'm doing clubs, so I need a C for the 13 clubs. But there's a whole bunch of other cards. So I'm going to need another C for the 26 other cards, because there's 13 hearts and 13 diamonds out there. Spades, I took 3. Clubs, I took 4. 3 and 4 make 7 cards selected. But if I'm dealing 13 to you, there's 6 other cards coming your way. If you punch that in, this, divide that, it should go .0741. This, I'm going to need to do 4 C's. I'm talking about 3 spades, so 13 C3, 4 clubs, 13 C4, 5 diamonds, 13 C5, but then there's others that I didn't name. There's still hearts. There's 13 hearts, and quick add, 3 plus 4 is 7, plus 5 is 12. I'm giving you 13 total cards, so that's 1. The 13 total cards is always appearing here. The fact that these are 13s is coincidence. That has to do with there's 13 spades. If you buy a deck of cards at the gas station, there's 13 hearts, 13 diamonds, 13 clubs, 13 spades. These 13s had nothing to do with that 13. That's just coincidental. But if you multiply this all out, it's a .005239. On the homework, when you get to number 29, they start to do probabilities. You're going to have a C on the bottom, and you're going to have probably 2 or more C's on the top for different groups. They'll start off with 2 groups, like they've got, I had the men and the women on the committee. They're doing boys and girls, they're doing blue and greens, they're doing left and right-handed people. They start off that way. But eventually you'll get to a card problem where there's more than 2 categories. There's maybe 4 categories on some of the card problems. But email me if you have questions or visit one of the Trig Zooms.